moment.
Are you going to do some introduction first, or am I just going to start?
Okay, a moment. Okay, we are online. Hello, friends. Welcome to SouJava channel with Ivar. Ivar, please introduce yourself.
Okay, hello and good morning. I'm pretty impressed that you are up this early to watch this stream. What I'm talking about today is microservice patterns implemented by Eclipse MicroProfile. My name is Ivar Grimstad, and I'm the Jakarta EE developer advocate at Eclipse Foundation. And some more words about me. This is my Twitter handle, so feel free to follow me there. I'm a member of the Java community process in the executive committee as a representative of Eclipse Foundation. I'm active in the Jakarta EE working group, and as I said, I'm the Jakarta EE developer advocate at Eclipse Foundation. And I'm also a Apache NetBeans committer, and I run a local Java user group here in Sweden called Java Forum Malmö. I'm also a Java champion, and as you see, this is my Twitter, GitHub, and LinkedIn, so please feel free to follow me there. So today I'll be talking about MicroProfile, and MicroProfile is a set of APIs that are aiming to solve common problems with microservices. So it's based on standard Java EE technologies such as CDI, JSON-P, JSRs, and JSON-B, which are all technologies that are useful to have when you implement a simple REST service. CDI for context and dependency injection, JSON-P for JSON processing, JSRs for creating your REST endpoints, and JSON-B for binding JSON objects. On top of this, you have 8 specifications for that solves common problems in microservice architectures, such as the open tracing solves the traceability issues, open API documents your services. You have REST clients for doing type-safe calls, configuration for externalized configuration, fault tolerance for circuit breakers and fallbacks, metrics for measuring your applications, and JSON Web Token propagations to secure your services, and health checks to ensure that your services are up and running before you start calling them. And all of these APIs and specifications solve some common problems that I'll introduce them using microservice patterns in this talk. But first, these specifications are backed up by a couple of implementations, or quite many implementations actually, and I'll be demoing 5 of them here today. And I've put up with the logotypes here. You can see Thorntail and Quarkus from Red Hat. We have Open Liberty from IBM, Pyara from Pyara, Apache Tommy from Atomic Tribe. You have Helidon from Oracle, and a couple of smaller ones such as Hammock, Cumulus EE, and Fujitsu Launcher. One thing that MicroProfile gives us, coming from the Java EE world, where we used to deploy into application servers, is that it gives you the opportunity to run your code from the command line using JavaDashstore. So it's a jar-based deployment. This is not specified, but it's something that the vendors that are implementing MicroProfile have chosen to do. So this is very convenient when you run it from command line, or run it in a Docker container, for example, that you can just run it as a Uber jar, fat jar, or hollow jar, or skinny jar, or whatever kind of jar you prefer. So to repeat, it's all about specifications. These 8 specifications on top, and I'll go through 5 of them here today in the context of microservice patterns. So, and the patterns I will be going through today are HealthCheck API, application metrics, externalized configuration, circuit breaker, and access token. And I'll do a lot of live coding going through these patterns. So I'll be switching back and forth, and I hope I can manage to do that properly with the screen sharing here. So just bear with me, and let's get going. So HealthCheck API. The problem statement for HealthCheck API is how to detect that a running service instance is unable to handle requests or able to handle requests. So a simple liveness probe or a live check is if you're running your services in an environment such as Kubernetes, you will have Kubernetes to check if your service is up and running or is alive. So Kubernetes will ask your service, are you alive? And it does that by doing an HTTP request to the HealthCheck liveness probe, which is the /health/live endpoint. And if your service doesn't answer within a reasonable amount of time, Kubernetes will kill the service because it's not up and running. So why bother spending resources on it? So it's pretty important that your health checks answers in pretty fast, so Kubernetes doesn't kill it. So this is a liveness probe of the health check. Another health check is the readiness probe. And that is when Kubernetes has established, yes, the service is alive, but can it accept traffic yet? So Kubernetes will ask, are you ready to have some traffic? And it can do that using the readiness test, which is /health/ready. And it will call your service there. And this doesn't have to be that quick to respond because Kubernetes will just ask it again if you're not ready. And whenever your service returns a 200 to this readiness test, it actually tells Kubernetes, hey, you can send traffic to me. And the distinction between these two services is that the liveness probe is just to check that the service is up and running, while the readiness probe is verifying that it can handle traffic. So you can do a lot of more checks in the readiness test to maybe load some caches or check other statuses of other systems and stuff, because it doesn't have to be as fast as the liveness probe. So it's very important to distinguish these two services. And to demo this, I'll use the HealthCheck 2.2 API, which is a part of MicroProfile 3.3, the latest version of MicroProfile. So I'll go into the demo. I'll just switch the screen. So let me just select here. So I hope you can see this. What I have here, I'll just go bigger, is a project I've downloaded from the MicroProfile starter. And I'm going to run it in, it's a simple hello controller, hello test. So I'll just fix this and just return hello Brazil, like this. I'll just take this out. So what I'm just returning here is hello Brazil. So I'll be running this in OpenLiberty, and OpenLiberty has this cool feature called development mode. So I can run it by Liberty Dev just using Maven like this. So while it's starting up, I'll use walk you through what's going on here. So you see I have the greetings REST application, which is a standard REST JSRs application. It says the /data is the root resource for my where my resources are, and the hello controller is under /hello. So this is just returning hello Brazil. So if I call this one, it's running on port 8181. So I can use HTTP on port 8081 /data/hello, and it should say hello Brazil. So the service is up and running. If I wanted to add a health check to this service, I could use the default, which is included by MicroProfile, and just call the health endpoint, which is en route. You will see it will return a health check for me. Actually haven't compiled there. So what I will do is to add a. You remember we had two health checks. The liveness probe, which is the liveness probe from annotation from MicroProfile, and you can see it's Eclipse MicroProfile health liveness. So the thing you do is you implement the health check interface. You override the health call method that returns a health check response, and you annotate it with @liveness. That means that I can call this liveness probe, this one, and you'll see it says Duke is alive. I'm just wondering why it is actually doing more than I thought it should. Let's say hello Brazil. So write this here as well and call it again. Okay, it's deploying. So yeah, you can see it says hello Brazil. So you can add your own data if you want to, but as I said, be careful not to do too much with the liveness test. So let's add a readiness probe as well. So it implements the same health check, the same call method, and you annotate it with @readiness, which is also MicroProfile health. And this one answers on the @ready endpoint. You see here that Duke is ready, which it says here. So this is the health check. It's pretty easy. You annotate it with @readiness or @liveness and just implement the health check interface. We switch back to the slides. So application metrics is the next pattern we'll go through. And the problem statement of application metrics is how to understand the behavior of an application and troubleshoot the problems. And to help with this, we have the metric specification of MicroProfile. And I'll switch back to the demo slides. So the metrics is it's very simple actually, because you have everything included in the MicroProfile. So what I can do here is to just ask for metrics. You see, I got a lot of Prometheus style metrics here, and we can look at some of them here. They are have the base underscore, and then here is the garbage collector total. That is the base metrics are metrics that are included in the specification, and every application has to include it. So if you move from one implementation like OpenLiberty to another one, such as Quarkus or something else, you will can rely on these metrics. There are also some vendor-specific metrics, and then they will differ from vendor to vendor. So if I wanted to add a application-specific metrics to my application here, you can see I have the @counted and the @counted will say give me a count for how many times have I called the say hello. And if I call the say hello again, Here we go. So I am calling the Hello Brazil method. And if I go into the metrics and I filter it by application, you see here that I have a total of 1 since I did a change of the say hello method. So if I call it again, you can see now that it should say 2. So by just adding a @count annotation, you can have business metrics in your application. There are other annotations for this as well. Just at metered would add a lot of metrics to your application. So I'll just go ahead and call this a couple of times. Sorry. Oh, I can't have both counted and metered, I guess. Let's see there. So I'm saying hello Brazil a couple of times. And if I go and look at the application metrics, you see I have a lot of them. I have the hello count that is a part of metered, and also have a rate per second and other metrics that could be interesting for your application. So there are more metrics offered by the metrics specification. You have the gauge and timed and etc. So it's up to you as an application developer or business to define what metrics are making sense for your application, and then you can use it. And it doesn't have to be on a REST endpoint like it is here. It can be wherever in any CDIB in your application. So I'll switch back to the slides. The next I'm going to show is externalized configuration. So externalized configuration is how to enable a service to run in multiple environments without modification. And the MicroProfile config specification, which is one of the oldest one in MicroProfile, it was part of MicroProfile 101, is the externalized configuration. And this works that you have 3 levels of defaults there. So you can put your configuration in a file package in your jar file in the MicroProfile config properties and configure your application there. This makes sense when you run on your laptop or in your development environment. So you just want to have quick access to the configurations and restart your servers all the time. So whenever you add stuff, you will you can just do the change there and it will pick it up. But when you move your application to another environment, for example, your testing environment, then you probably want to you can use environment variables, for example, in your Docker containers, or system properties in your staging and production environments. And these properties will override each other. So whenever you have set a variable in the application configuration, if there is an environment variable with the same name, it will override it, and a system variable will override that again. And if you have in your production environment some other configuration system, it's very easy to just create a configuration source that overrides all of this. So you can put your configurations in, for example, a secure vault to have your passwords encrypted and etc. So it's very easy to override this. Let's look at the externalized configuration. So I have my application running here. So let's configure this one. So if I go in here and say, I want to inject a variable, a string, and I'll call this this variable, for example, location. And I'll annotate this with config property name is location. I'll give it a default value is let's say internet. So I'm just configuring it like this. So if I now say hello Brazil, rather than saying hello Brazil, I'm saying hello plus location. And maybe I'll have an exclamation mark at the end as well. If I now run my hello service, it will say, oh, sorry, oh, maybe not have a compilation error. That usually helps. So there we go. It says hello internet. So if I want to configure this one, I'll just stop my service again, and I'll give it a system property. So what I'll actually do first is to go into my, I'll start it again. There we go. Go into the configuration here, and I'll say that I want to give the location property, set it to Brazil. And if we look at the code again, you see it fixed the location. It's a location variable. I'm setting it here. Location equals Brazil. I give it the default value to internet. So if I run this now, sorry, isn't that running? It should be up. Oh, there we go. Here it says hello Brazil again, since it's now picking up the value of the location configuration. If I now want to configure this one in a different environment, I'll just stop the server again, like this. And if I now run it with a system property and say location is SouJava, it will now take this system property and pick it up from the location. It will override the location in my configuration file, and it will also override the default value. So let's just wait for it to get up and running. And as soon as it's ready, it should be any second now, it should be able to say hello to Java. Still says hello Brazil. Let me see. We can get it up. It could be that the development plugin of Liberty doesn't pick it up from the system properties. To solve this, I could actually do run it from command line with JavaDashstore. Just build it first. And while this is going on, I can explain a little bit about the differences here with the different implementations. So this one is using MicroProfile. It's running on Java 13, actually on 14 on my environment. It's using MicroProfile 3.2. So this is something you would be familiar with from Java EE or Jakarta EE, is that you're using a provided dependency and let the implementation take care of the implementation for it. And the Open Liberty has their own plugin and tooling for running this application and building it. And the other implementations will have different things. But what is common for all is the provided dependency for MicroProfile. So if I run this one with minus the location is SouJava, minus jar target, and this one is called greeting jar. So what I do is now I give the system property to start it up, and this will override the local application configuration here, if we're lucky. So for a different implementation, such as Payara, for example, you would have the Payara specific tooling for creating the application. So if I now go and say data hello, it should say hello SouJava. This is how you configure the system by overriding it. So let's just stop this one again. Sorry, and I'll go back to the slides and go to the next pattern. So the next I'm going to talk about is circuit breaker. And the circuit breaker is how to prevent a network or service failure from cascading to other services. And you probably have a circuit breaker of some sort in your home, like these fuses here. So if you put on the dishwasher, the microwave and the washing machine and start cooking your pizza or your grilled meat or whatever you're doing, you probably are going to overload the system, so the fuses will go and the circuits will open. And this is to prevent your host from burning down. And the same thing is with the microservices, is that if one service gets into trouble, it shouldn't cause the entire system to go down. So what the circuit breakers will do is to open up the circuit so you don't send calls to this service anymore, and have some fallback mechanism so it will do something else. So the user will maybe not experience any bigger problems with the service. And the fault tolerance specification on MicroProfile implements this. And I'll go back to the demo, and this is a little bit more advanced. Before I go there, I want to show what I'm going to do. So I'm going to start up a couple of services. I'm going to run a location service in Quarkus, and this set of services or application is kind of inspired of my life as a developer advocate. It's not very relevant right now because I'm pretty much stuck at home because of the COVID-19 situation. So this would actually say the location service would always be at home. But when I'm out traveling and you wake up at a hotel in the morning, you probably have the experience that you wake up and you don't know where you are. So you want to just figure out an easy way without getting out of bed, where am I? And the easiest way for me is just to have a service on my laptop, start it up, and it will tell me where I am. And this one says at SouJava. If I were to visit you in Sao Paulo, it would say Sao Paulo. And then I also, the next question is, what am I doing here? And often is that I'm speaking at a conference. So I would have a service that says you have a microservice talk at SouJava or the conference I'm at. So I'm also running this service using Helodon that will call the location service to figure out where I am, and it will tell me what I'm doing and where I am. And I also need a couple of services, one to tell me which day it is, and also what time is it. And I'll run the day service in Tommy and the time service in Payara. And then I'll modify the greeting service. So it will call the conference service to figure out that I have a microservice talk at SouJava, and the conference service will then call the location service. And the other call it will do is that it will call the day service to figure out which day it is, and the time service to figure out what time it is, and then compose a message saying you have a microservice talk at SouJava Monday at 7 a.m. So that is what I'm going to build using the fallback. And you see here from the greeting service, I have fallbacks to the conference, the day, and the time service. So it will give me some alternatives in case these servers are not down, because this is pretty complex for a solution for a simple problem. So let's look at this code. First of all, I'll go and have a look at the location service. So the location service is just returning the place I am. So it has a default of somewhere, because if I don't say where I am when I go to bed, the service won't know where I am. So the location service just returns somewhere unless I've stated something, and it will return the configure property of where I am. So if I go in and look, and I'll run this one in Quarkus, so I can use the Quarkus dev mode. And the Quarkus dev mode is pretty much similar to the Open Liberty dev mode. So, but this one actually works with the system properties at SouJava. So I can configure it like this and say, hey, run up and do this for me. And while it's starting, I'll go into the day service and have a look at that. So the day service will run on, I think that was Tommy, and it will actually take the day it is today. So it will return today's date. So I'll go in and just start this one. I'll run this one as a jar. And this was the exec jar. And let's also look at the time service and start that one up. So the time application, oh, there we go, the time control will say the clock is at 7. So I'll start this one as well. This jar target, and this is time. And microprofile jar and port equals 8383. So I have the day service up and running. I have the location service up and running. Let's call these. First, let's call the location service. And this is on 8484 data location, and it will say somewhere. So it hasn't been configured properly. That's weird. I'll look into that. And let's look at the day service, which is, you'd say, Wednesday, 8080. Day. It's Monday, which is true. And let's go to the time service, which is on port 8383 data time. We should say, oh, let's go here and see. Oh, it's not running. I just have to check where. I might check my notes here to compare why the port command didn't work. Sorry about this. A bit too much going on here. Let's see. The I think. See if it starts. And at the same time, go in and see why wouldn't the configured service go. Still says somewhere. Let's go, and it's not going too well for me today. So let's go and take the start location service and go in and configure it with this is is at Java. There we go. See if the location service will run. It's not going too well for me here. Oh, it's not on 84. Oh, it is. Oh, crap. So what I'll do is that you just have to believe me that this actually works, and I'll hardcode it like this. So it returns SouJava. Just don't look at the hardcoding. Sorry about that. I'll just have to figure out why this one didn't answer. Let's see if 84 data time. 83 of all these ports numbers. Data time. There you go. It returns 0700. So I have a time service returning 0700. I have a location service returning at SouJava, and I have a day service returning the Monday. So let's look at the conference service, and now it's when it's getting interesting. So the conference service is saying you have a microservice talk, and then it calls the location service to say where is this talk. And here I'm using the types of REST client of MicroProfile, where I have a interface using the JSRs at path or at get annotation, and the at path to say that this is the slash location. Yeah, you remember here, it's the slash location here. So this is the path element of the service. I'm saying register is as a REST client, send all the headers over, and just make it a CDI bin. So this is standard JSRs things. So and what this will do is to generate a proxy for me to call this service. And the way I configure it is that I, in the MicroProfile config properties, say that the location service, which is this interface, is on this URL. So you see it's on 8484/data, and then /location will pick from the interface. And this will it's just a regular Java interface that I can use from the hello controller here, but just injecting the location service and calling it in a typeset way. So you see I have the application method, which is the method I have here. So I can call it directly. So this one, I'll just start this. It's running on in Hello, and you see I'm using Java 14 here. And target, this is conference jar. The conference service will say I have a microservice talk and then call a location service and get the location. So if I go here and say to 82/data location conference, and you can see it says a microservice talk at SouJava. So all the services are up and running. The greeting service is the one I looked at in the beginning. So let's go to the greeting service and just fix that one. So rather than saying just hello this location, let's say hello, you have a, and then call them the conference service. And if you remember, the conference service will say microservice talk at SouJava, and then call the day service, which will return Monday, and then return the time service, which will return 0700. So this will say you have a conference service, you have a microservice talk at SouJava, Monday at 7. And the way it does this is to use the same REST clients to call the conference service, the time service, and the day service, the same way I explained before. So if I go here and call this one, it1 data, hello, it will say, we have a microservice talk at SouJava Monday at 0700. So this is very well. I have 5 services up and running, and everything looks fine. But what happens now if I take the time service and just kill it? But the time service is not running. What will the message be here? See, it will say you have a microservice talk at SouJava Monday at ? But where did the question mark come from? Well, let's look at the time service and how that has been set up. So you see it has the add path, register REST client, register client headers, and dependent, exactly the same as the location service I showed earlier. It has the @get annotation, all is standard JSRs. But here's something. I've added the @fallback, and I'm saying, call this fallback method now. And the fallback method is a default method, and it says return ? And that is, if this one doesn't return anything, return this. That is why you get the question marks there. So if I start up this again, and after a while, it will return 0700 when it's up and running, without me having to restart anything. The same way is done with the day service. So if the day service, you can see it has a fallback method here saying call today and return the text today. So if I take down the day service and call this one, it will say you have a microservice talk at SouJava today at ? The time service is not up and running yet. And then the last one, the conference service. Here I have actually a timeout of half a second. So if it times out or it's not up running, the fallback method say it will be called, which is said, did look out the window. If you don't know where you are, you need to look out the window. So if I close down the conference service and I call this one, it will say you have did look out the window today at 700. So you see it will return the 0700 because the time service is up and running. The day service hasn't been started yet. So if I start this one, when it's up and running, you can see it will say you have dude look out the window, and then it will say Monday at 700 because the day service is up and running. So let's just give it some time to get it up, and I think we're good to go. So now it will start looking good, and then if I start up the conference service again, it will. When it's up and running, you will see the text will change to say you have a microservice talk at SouJava. It's still starting. There you go. You have a microservice talk at SouJava Monday. So this is how fallback works. You see, I'm not touching the greeting service. It just happens to go up and down when I fix the other services. So let's go back to the slides. So the last pattern I'll go through today is the access token. And the problem statement of access token is how to communicate the identity of the requester to the services that handle the request. And to just put some ground around this, I'll go through some authentication mechanism. So the first one you're probably familiar with is basic authentication. And basic authentication, the technical stuff behind that is that in the HTTP request, in the header, you have a authorization and the keyword basic, and then you have some password that is base64 encoded or hashed somehow. So this is kind of the technical thing. You have the authorization header that the application will read out and validate the password. and you send the password everywhere. So it's not very secure. Service to service behind a firewall, it's okay, but it doesn't give you any information other than that somebody knows this password. So then comes OAuth 2.0, and OAuth 2.0 is technically exactly the same as the basic authentication when it comes to the HTTP part of it. It just has the authorization bearer and a little bit stronger encryption on the password, but it's still a password, and you have more password because you have a refresh token. So when this password has timed out, your application will send a refresh and get a new password. So, but this is kind of the application keeps track of these passwords for you, so you don't have to do anything. But it's still just a password. It's saying, hey, you know the password. I don't know anything else about you. And technically, it's just basic or bearer. Then we have JSON Web Tokens. And JSON Web Tokens is a little bit more advanced. First of all, it's a longer token, but it's actually exactly the same as with OAuth. And you haven't even changed the keyword bearer. So it's authorization, bearer, and then you have a long token. But if you look closely here, you can see there are a couple of dots. And I'll put on some colors here. So you can see after the first purple string, there is a dot. And then you have the green part, and then the blue part. So it's kind of divided into three. And the first one is a header. It's a base64 URL encoded JSON. And it says something about this token, what kind of token it is, and what algorithm is used. Then you have the green stuff, which is the payload. And this is also a base64 URL encoded JSON. And you have some standard entries that have to be there, and you have some custom entries that may be there. And at the end, you have the digital signature, which is binary, and it's base64 URL encoded. But this is the signature that makes you able to verify that the token hasn't been tampered with on the way. What's interesting about the tokens, this is how it looks in the HTTP request. This is how it looks if you unencode it. So at the top you have the algorithm, which in this case it says is a JSON Web Token and it's RS-256 that is used as algorithm. Then you have some properties like the expiration dates and things like this that are mandatory by the specification. And then you can have custom entries like the username here, in this case Duke, and you can have scopes and etc. And in MicroProfile they have defined a entry called groups. So you can say that this user is a part of some groups. So it has some information in there that you can use in your application, or the infrastructure architecture can use to verify more about this person. Like, am I allowed to call this code, for example? And the blue is a digital signature. And let's look at the JSON Web Token propagation specification to see how we can use this. And in this demo, I'll use the same application as I used in the previous example, only I'll secure one of the services. And the service that is most kind of vulnerable for me is the location service, because I don't necessarily want everybody to know where I am. So let's add some security to the location service and say that you have to have a specific role to call this, otherwise I won't allow you. And in order to check this, I will add a JSON Web Token to the greeting request, which will be propagated to the conference and further on to the location service and be validated there before before the text is returned. So let's look how this will be in code. So first of all, I want to secure the location service, and the way I do this is in the resources I add a public key, and since this one is using Quarkus, they are using this way of configuring. So I'm saying the issuer and the is server example.com, and the public key is here. So the public key is something I'm giving and configuring my application with. And then I'm saying, in order to call this service, you have to have the role protected. And the role protected is something I can extract from a JSON Web Token. And to show you this, I will actually change my screen again. I will take it to a token I have generated, and I'll just stop sharing for a minute, a second, I hope. Let's see. Go in there and go to a website called jwt.io. And here I can verify my tokens. So I'll just have a token I've generated here. And you can look at this. It has the issuer, and it has these groups I was talking about, the user and the protected. So the user that has this token has the protected group. And what MicroProfile JSON Web Token propagation will do is to take this role and hook it into Java EE security, so I can use it in the @roles_allowed annotations. So I'll use this token to send with the requests. So I'll go back to the code. So if you look at this one, let me just see that I'm sharing the correct screen. There you go. So what I'm saying is @roles_allowed protected. So the @roles_allowed is Java EE security. And if I have this @roles_allowed protected, if I now do a call to the location service, 84 data location, it will say that I'm unauthorized because I haven't provided a token. I've added security here, and I don't have this in the request. If I add this in the token in the request and say I'm doing the same call, but this time I'm adding a authorization header. I'm saying it's bearer, and then I'll paste the token and send it in, and it will return @SouJava because now I have the correct role. If I here add a tampered token, let's say it doesn't have a G at the end of the Q. Oh, maybe it was a Q. It's unauthorized. So I have to send the correct token, otherwise it won't be accepted. And let's look at how I can do this from the other. As you remember, the location service is called from the conference service. So the conference service, what do I have to do there? Well, actually nothing. I just propagate the token through. So I don't have to do any configuration. I don't have to have any public keys or anything here. And in the greeting, actually I don't have to do anything either, because the only thing I've changed so far is to add the @roles_allowed in the location service. So what happens now if I do call the greeting service? Let's say it says, hey, dude, look out the window. And this is because the fallback kicks in. If you remember, the conference service here says that dude, look out the window, unless I get an answer here. And I don't get an answer. I don't get a 500. I get a 401 unauthorized, and that's what this happens. So what happens is that I have to add the token here the same way I did. So authorization, bearer, and then the token, like this. And You see now it says you have a microservice talk at SouJava on Monday at 700. So by adding the token, I can do it, and you saw how simple it is. It's a very simple configuration saying that I have I have to add which key I'm using, and I have to do the address load, and I can also get this one to return things from the JSON Web Token. So it's very easy to get started using, and I can just encourage you to start playing around with it. So to sum up, what I've gone through here are 5 of the specifications. And you see they map correctly into 5 different patterns. I showed the externalized configuration, I showed you health checks, I showed you JSON Web Token propagation, showed you application metrics and fault tolerance. And these are the patterns that are implementing these 5 specifications. You can find more information about the microservice patterns at http://microservices.io. And the samples are on my GitHub. And MicroProfile is best found at microprofile.io. And if you're interested in what's going on with Jakarta EE, I suggest that you look at https://jakarta.ee. So that was what I had for today.
Okay.
Yes.
Three questions.
Yes.
A moment.
Okay, this is a question regarding Istio. I actually don't know exactly. I don't think I can answer this one. I'm not very much familiar with Istio, so I would say go with what's the common practice and what is recommended to you use.
Okay.
Okay, time service fallback, for example, sounds like a business decision. Yes, it can be, because if you look at, for example, let's look at Netflix. Everybody does Netflix. So if the service that shows you your favorites shows or something is not up and running, then Netflix can show some guesstimate of what your favorite shows is. So it's kind of a business decision, which what you want to return from the fallback, unless the if the real service isn't answered. So yes, it is a business decision. Yes.
Okay.
Okay. Yeah. So about the alignment with Jakarta EE, I think I'd like to waive that question there right now. I can explain the pull push strategy. It's a decision the microprofile community did when they were deciding on their alignment with Jakarta EE, and the pull decision is that they want to be controlling their own life cycle and push out applications at their will, which is perfectly fine. The push approach would be that they were establishing standards, and then when they consider it to be good enough, they would push it to some other standardization organization, for example, Jakarta EE. They chose the pull strategy. So the consequence of this is that the Jakarta EE community has to decide how will Jakarta EE be aligning towards MicroProfile and other specifications, and that is a question that hasn't been decided yet. I think that is something we will be discussing in the future. I know that on Friday I am going to do a Jakarta EE panel or Q&A at SouJava. So I invite you to join there. I guess the question will come up there.
Okay. Friends, more questions? Okay. No more questions.
Okay.
Ivar, you see a moment. Do you want to say something final?
Sorry?
Private chat.
Okay, final comment. Well, I hope you've enjoyed this, and I would really encourage you to be involved in both MicroProfile as well as Jakarta EE. And as you probably know, there are elections up now for the Jakarta EE working group. So if you're a committer on any EE4J or Jakarta projects, I encourage you to nominate yourself to be a part of the working group, either the steering committee, the spec committee, or the marketing committee. They all have open seats for a committer, and you can, on Friday is the last day to nominate yourself. So if you want to be involved, boost your career, go ahead and join the working group. Another thing I want to encourage you to do the Jakarta EE developer survey. I'll paste a link in the chat here if you can find that. So this is your way of getting your voice out there. Show what what you think about the future and technologies, and give input to what we should focus on in the future.
Okay. Okay. Thank you so much for lecturing. It was very good.
Thank you.
Thank you. Bye.
Bye.
Bye.